Now that we've had a look at what a significant figure is and how to identify significant figures, it's important that we look at how we deal with significant figures when we calculate. Before we start, if you're asked to write a number with a specific number of digits, regardless of whether it's because of our uncertainty ranges or because of sig figs, we'll talk more about this in just a second, often we have to round those numbers off. I know that there's lots of different rules that you've encountered along the way regarding how to round numbers, but we all have to have a certain agreed upon set of rules, and we're going to use this particular convention. So when the first digit after the one we're retaining is less than a 5, then the digit we're keeping is going to stay the same. When the digit after those that we're retaining, the first digit after those we're retaining is greater than 5, the last retained digit will be increased by 1. In other words, we're going to round it up. So looking at the first example, and in both cases we're going to look at 2.249. If you're asked to keep two significant figures, work with me on that assumption for right now, I would want to keep the 2 and the 2. Which means that the question is that 2 going to stay the same or will it round up? Looking only at the number directly behind it, that 4 is less than 5, and so the 2 stays the same. So we write 2.2. Now on the flip side, if you're asked to keep three significant figures, again, work with me on the assumption for right now as to why you would want to do that. We'll want to keep the 2 and the 2 and the 4's position. We have to look at the number directly behind the 4, in other words the 9, which is obviously greater than 5, which means that our 4 rounds up to a 5. Sometimes it's necessary to write the number in scientific notation in order to indicate the correct number of sig figs in the measurement. 3,600, for example, as it's written, 3600, has 2 sig figs because these zeros are placeholders, not significant. So that's 2 sig figs. If, however, we write 3600 decimal place, that's 4 significant digits. Though that decimal is to indicate extra effort in our measurement, and so that means that the zeros are significant. If I need to write it so that I have 3 sig figs, I must use scientific notation in order to do that. And the nice thing about scientific notation is that anything written in the mantissa at the front is considered to be significant. So now let's think about how to deal with this in addition and subtraction and multiplication questions where you actually have to do a calculation. And there's two distinct rules here. One for addition and subtraction, one for multiplying and dividing. The rule for adding and subtracting is that the final answer can only have as many decimal places, and let's also kind of mentally add here that this could be place values, so hundreds or tens if it's not on the right of the decimal, as the number with the least decimal places. If I look at 120.0, I have one digit beyond the decimal. When I'm adding that to 2.625, that has 3 numbers to the right of the decimal place. Based on this rule, I can only have one number beyond the decimal because it's 1 is less than 3 positions. So I need to round off to the 6. The explanation for that is that we can remember that significant figures include all the numbers that you're sure of and one uncertain digit. And that uncertain digit is always the last one, which means that that 0 that I'm adding to the 6 is actually uncertain. If I don't know that that 0 is exactly a 0, then I don't know that the 6 that is the product of adding the two numbers together is actually a 6. And if I don't know that's exactly a 6, I can't include anything after it. Now we have to round it off. So 122.6, I look at the number directly behind the 6 and it's a 2, which is less than 5, so it stays the same. I'm going to give you just one more complicated example here. If I take, for example, 320 and I add 15 to it, in your calculator, that would give you 335. When I consider this, I need to remember that it's where I have my last decimal place or place value, and that should be my last significant place value. So this is in the tens position. This 5 is in the ones position. The tens position is less decimal places, which means that I can only write my answer to the tens position. As per our rule, I'm going to include 3 and the 3, but looking at the rounding, what does the rounding do? Well, that turns that into a 4. Okay, now 34 and 335 are very different sizes of numbers, and that's because I need something to hold it in its place. I need something to keep that 4 over in the tens position. Look, a placeholder 0. That is not a significant digit, remember? It's just a placeholder. So multiplication and division are large-scale changes. So I have to look here at the big picture, at the sig figs. And my final answer can only have as many sig figs as the number with the least sig figs. When I consider 120.0 times 2.0, I get, if I did longhand division, 240.0. 120.0 has 4 sig figs, because the 0 at the end is an extra effort 0, which makes the one before it a trap 0. 2.0 has 2 sig figs, because again, that 0 is an extra effort 0, one I didn't have to write, but I did to show I'd put in extra care in my measurement. Which of those is less? Well, 2, so I can only have 2 sig figs in my answer. When I write this out, that means I keep the 2 and the 4, and I need to keep that 4 over in the correct place value. So what can I put in? Well, a placeholder 0. Do not make the mistake of throwing a decimal place there, because that would make that 0 significant, which I don't want it to be. So that is the basics of how to deal with significant figures in calculations. This is going to require a lot of practice for you, and although I know that you'll assume that you get it right away, I'm really going to encourage you to complete all the practice that has been provided so that you can reinforce the skills and actually do it properly when you're asked to later on.